Hi friends, good morning to everyone. Welcome to my channel, Belagali's class. My friends, I have started with a circle for the 10th standard students. Circles have started. Given the basic definitions, what is center, radius, diameter, chord, secant, everything about the circle, those basic concepts I have explained, my friends. After that, I have done two theorems. Theorem number 1 and theorem number 2. After doing theorem number 1 and theorem number 2, I have started with doing the examples. Exercise 4.1 in your textbook. I have completed all examples from exercise 4.1. Now I have started with examples under exercise 4.2. Exercise 4.2. One example I have done yesterday, my friends. Before starting with these examples under what? Exercise 4.2, once again I want to explain what is theorem 1 and what is theorem 2. What is theorem 1? Radius drawn through the point of contact. Radius drawn through the point of contact is perpendicular to the tangent at Q. Perpendicular to the tangent at Q. So in this case, OQ is perpendicular to the tangent PQ. Down OR. OR is what? It is the second radius perpendicular to what? Tangent PR. Tangent PR. Therefore, when it is perpendicular means we are saying angle OQP is 90 degrees. ORP is also 90 degrees. This is theorem number 1, my friends. Theorem number 1. So what is theorem number 2? For the point outside the circle, we can draw two tangents to the circle. One tangent is PQ, one tangent is PR. And we have proved these two length of the tangents PR equal to length of the tangent PQ equal to PR. This is 1. And also I told what? This OP line, OP bisects the angle QPR. What is that? OP bisects the angle what? QPR. Therefore, angle OPQ equal to angle OPR. This. At the same time, my friends, one more is also true. What is that one more? Even angle at the center, they are also equal, my friends. This angle equal to this angle. What is that? Angle QOP equal to angle ROP. 510. We made, my friends, these two triangles congruent. While proving this second theorem, we have shown these two triangles, my friends. These two triangles are congruent. Triangles are congruent means what? Corresponding angle, sides, everything equal. Therefore, as these two angles are equal means it is a bisection. These two angles are equal means it is a bisection. Bisection at P, even bisection at what? Angle at the center of the circle. What is this O? This is bisection of angle at the center of the circle. Please, my friends, remember these points. What is 1? Radius is perpendicular to the tangent. That is first. Length of the tangent drawn from the outside, point outside to the circle. Those length of the tangents are equal. What is third? This OP bisects angle at P as well as central angle at O. Bisects means two equal angles. Remember, my friends. Then this is the second example. In the figure, if TP, TQ are the two tangents to the arc, this is your arc, my friends. This is the arc. Whose center is at O? Such that angle POQ is 110 degrees. POQ is 110 degrees. Then we wanted to find what is the angle PTQ, this opposite. PTQ, what is that angle? These are the options, my friends. First option is 60, second 70, third 80, fourth is 90 degrees. 90 degrees. Yes, my friend, same that corner, both the theorems, theorem 1 and theorem 2 are the main result source. Yes, my friends. OP perpendicular to PT. OQ perpendicular to TQ. Therefore, here I have written OP perpendicular to PT, OQ perpendicular to Q2 implies this angle OPT is 90 degrees. This angle OQT is also what? 90 degrees. This is 90, this is 90. My friend, this angle is given as what? 110, 110. Then automatically what, my friends? 90, 90, 180, 180 plus 110, 290. It is a 360 minus 290 means the angle is what? 70 degrees. I will explain here. This OPTQ is a quadrilateral. Therefore, sum of interior angles is 360 degrees. First angle, this OPT plus second PTQ plus third OQT, fourth POQ. These are the four angles. Sum of the four angles in a quadrilateral is what? 360 degrees. This is 90. This we wanted. OQT. This is 90 plus. This is POQ is what? 110. This is angle PTQ plus 90 plus 90, 180 plus 10, 190 plus 100, 290 equal to 360. Therefore, this angle equal to 360 minus 290 is 70 degrees. This is 70 degrees, my friends. Very simple examples. Simple. This is the example appeared 2020. March 2020 means what? May or March last year. 2020 means last year question paper. What is the change? Change given instead of 110, the friend is given 130 degrees. 130 degrees. Instead of these, my friends, the friend is denoted these points as what? This is A, this is B, this is C. Then the friend wanted what is angle? Angle BAC. 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 Yes. The same method, my friends. This will try. Anyway, you try with what? This itself. Instead of 110, it is given 130. My friends, this is 130. 90, 90, 180 plus 130. 210, 310. 360 minus 310 is what? Instead of 70, you will have 50 degrees. 50 degrees. 50 degrees, my friends. This is first example. Second example in exercise 4.2. Next, this is third example in 4.2. If tangents PA, PB from the point P to a circle with center O are inclined to each other at an angle 80 degrees. Then, what is the value of the angle? POA. POA. This is the figure, my friends. From the point P, PA, PB are the tangents which are inclined to each other. This man, angle between them is what, my friends? 80 degrees. This is 80 degrees. This is 80 degrees. Then you wanted what is angle POA? POA. This angle, my friends, question mark. It is also quite simple. Again, what is this? 90. What is this? 40. What is 90 plus 40? 130. What is the sum of all the three angles? 180. 180 minus 130 is what? 50 degrees. 50 degrees. So simple. Same thing I have written. Once again, my friend, OA perpendicular to AP. So this angle is what? 90 degrees. angle OAP is 90 degrees. Given angle APB, this angle APB is 80 degrees. But this OP bisects the angle APB. Therefore, each angle bisect between two equal parts. Angle APO equal to angle BPO equal to what? Bisection means two equal parts. 80 upon 2. What is 80 upon 2? 40 degrees. Now in triangle OAP, angle OAP plus angle this APO plus angle what is this? POA, my friends. This plus this equal to 180 degrees. But what is the value of this? 90 degrees. But what is the value of this? 40 degrees. Therefore, this angle equal to 180 minus 130, which is 50 degrees. Therefore, what is the answer, my friends? A is your option. A is your option. Both examples copied it. 1 minute time. 1 minute. That results are very important, my friends. Very important. Next, this is example number 4. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. Just, my friends, I want to remind these are the two parallel lines. If a line cuts these two parallel lines, what these? Corresponding angles. What about these? These are alternative angles. If the alternative angles are equal, these two angles are equal, lines are parallel. If the corresponding angles are equal, lines are parallel. Have this in the mind. I tell my friends, you wanted to prove tangents drawn at the ends of the diameter are parallel. In proving, we use this. One is corresponding angle. If the corresponding angles are equal, lines are parallel. If the alternative angles here, in interior alternative angles are equal, then the lines are parallel. Yes, my friend, just to have it in the mind. This is the circle. This is the circle. This is the diameter, center. Diameter of the circle. This is one tangent at one end of the diameter, tangent at other end of the diameter, Then you wanted to prove these two tangents are parallel. This is AB is the diameter with center of the circle is O. Then PQ is tangent at A. RS is tangent at B. Then you want to prove PQ is parallel to RS. Yes, my friends. Yes. Let PQ and RS be the tangents. At the ends of a diameter. Ends of the diameter AB. Yes. PQ is at A, RS is at B. Yes. Now we want to prove PQ parallel to RS. Yes, my friends. Proof. Same once again. PQ is tangent and OA is the radius. My friend. This PQ is perpendicular to OA. Right. Now by the theorem 1, radius OA is perpendicular to PQ. Therefore, angle I take PAO. Angle PAO is 90 degrees. That is angle PA, that O I will take up to B, same line, is 90 degrees. This is 1. And what is that? OB is perpendicular to RS. Implies angle I take this angle, what is it? OBS. Angle OBS is 90 degrees. Instead of OBS, I take it as what? That is, I take from here angle ABS. ABS is 90 degrees. Therefore, my friends, you can combine both. Angle PAB equal to angle ABS, or instead of ABS, okay. This is what I have started with a P. Okay, I do one change here. I start with S. This is SBO, 90 degrees. Same thing. That O I will extend, that is angle SBA is 90 degrees. So this is PAB is 90 degrees and SBA is 90 degrees. And then both are equal. SBA, both are equal to 90 degrees. But what about these two? This is one angle, interior angle. What is this? It is another angle, another interior angle. What about these two? They are nothing but what, my friends? Alternative angles. But angles PAB and SBA are alternative angles, interior alternative angles. interior alternative angles. Alternative angles. Alternative angles, this itself implies what, my friends? The line PQ is parallel to line RS. PQ is parallel to RS. This is the method, my friends. So this is what? PAP is equal to SBA. Then these two are nothing but what? Interior alternative angles. So alternative means what? These two lines are parallel, because by using this, my friends, by using this, I will explain once again. Prove that the tangents drawn at the ends of a diameter of a circle are parallel. This is your circle with a center O. PQ, PR are the tangents at the ends of the diameter AB. You want to prove PQ is parallel to RS. OA perpendicular to PQ. Fine, theorem number 1. Then angle PAO is 90 degrees. Extend that O to this side. PAB is 90 degrees. Second, OB is perpendicular to RS. Therefore, angle SBO is 90 degrees. Continue up to this because it is on the same line. A is 90 degrees. Therefore, both are equal to the 90 degrees. These two are nothing but the interior alternative angles. When they are interior alternative angles, you can say that these two lines are parallel. This is the proof, my friends. Copy it. Yes. Next. This is fourth example, my friends. Next is fifth example. Fifth. Prove that. Prove that the perpendicular at the point of contact at the point of contact to the tangent of a circle of a circle passes through the center. You want to prove this. Passes through the center. Prove that perpendicular, this my friend, where at the point of contact to the tangent of a circle passes through the center of a circle. Yes, my friends. This is the figure. We can draw the tangent anywhere. This is the tangent to the circle. This is center of the circle. This is tangent to the circle. This is tangent even. Tangent to the circle at the point P. This is the point of contact. Then you wanted to prove perpendicular from P, which is on the tangent passes through the circle. Perpendicular from P, you wanted to prove, this is O. Perpendicular from here, you wanted to prove, it passes through the center of the circle. Center of the circle, you wanted to prove this. Yes, my friends. Assume, if possible, there is another point O dash, where this perpendicular from P passes through O dash. If possible, then you have to show that OA and O dash P or O and O dash are same, they coincide. We want to prove it. Yes, my friends. Consider a circle with center O. Consider a circle with center O. With center O. Let AB be the tangent at P. AB be the tangent at P, at the point P. Let O dash be another point inside the circle, as shown in the figure. Let O dash be the another point inside the circle. Inside the circle as shown in the figure. As shown in the figure. Join OP and OA. OP and O dash P. Assume that perpendicular from P passes through O dash. Therefore, angle, tell my friend, angle O dash, this assume perpendicular from P passes through the point O dash. Therefore, angle O dash PB is 90 degrees. But according to your theorem number 1, what is OP is radius? OP is radius. Implies OP is perpendicular to the tangent at P, implies angle OPB is 90 degrees. See, O dash PB is 90, OPB is 90, then both are equal. Therefore, we have angle O-PB equal to angle OPB, both are equal to 90. This is possible only when both are equal to 90 means what? It is possible only when O and O dash coincides, or O dash and O coincides. Yes, my friends, this is possible. This is possible only when therefore, this is possible therefore, this is possible. This is possible only when O dash coincides with O. Yes, my friends. Then our assumption is wrong. What is our assumption? Yes. Let O dash be another point. Yes, here. Assume that perpendicular from P passes through the O dash is wrong. Therefore, our assumption coincides means what? Our assumption perpendicular from P passes through O dash. Is wrong. This implies which is correct. Perpendicular from P passes through O. This is correct, man. Now we want to prove the same. Tangent passes through the center. O passes through O. If you want it in detail, perpendicular from P, where it is a tangent, passes through the center of the circle. Hence the proof. Hence the proof. Let's copy it 1 minute. I will explain once again. Yes, friends, you want to prove this. Prove that the perpendicular at the point of contact to the tangent of a circle passes through the center of the circle. This is the figure. Center of the circle, tangent at P. You want to prove perpendicular from P passes through O. We want to prove. To prove perpendicular from P passes through the center O. Yes. Circle with a center O given. AB be the tangent at P. We want to prove what? A perpendicular from P passes through the point O. We wanted to prove. If possible, assume that perpendicular from P passes through another point O dash. passes through another point O dash. If you wanted, you can write here. What you want to prove here? You want to prove that perpendicular from P passes through the center O. We wanted to prove. To prove that, assume O dash be the another point inside the circle as shown in the figure. Join these two. Assume that perpendicular from P passes through O dash. We want to prove O, but our assumption through O dash. Then this angle with O dash is 90 degrees. But what is this? OP is a radius. When it is a radius, then it is perpendicular to the tangent. Therefore, this angle is 90. Both are equal to 90 means what? Both the angles are equal. This is possible only when O dash coincides with O. O dash coincides with O. When O dash coincides, in that case, our assumption that perpendicular from P passes through the O dash is wrong. Then what is correct? Correct is perpendicular from P, which is a point of contact of tangent, passes through the center of the circle. Hence the proof I have not written in detail, that itself indicates. Yes, my friends. Now this is fifth example. Next is sixth example. Right. Example number 6. The length of tangent from the point O, from the point O from the point A at a distance at a distance 5 centimeter from the center of the circle is 4 centimeter. Find the radius of the circle. The radius of the circle. Radius of the circle. Yes, friends, read it. Read it. The length of tangent from the point A is at a distance 5 centimeters from the center of the circle is 4 centimeters. Yes, my friends, this is the circle. Yes, center of the circle. Normally we have not changed it. It is always O. Tangent from the point A. It is from the point A. A is outside. A is outside. A is outside from A at a distance 5 centimeter. This A is at a distance 5 centimeters from the center of the circle. 5 centimeters from the center of the circle. This is 5 centimeter. Then what is given? Center of the circle is this length of the tangent from A to the circle. This is B. This is 4 centimeters. We wanted to find what is the radius of the circle. What is the radius of the circle? This is point of contact B. Point of contact B, and this angle is, my friends, 90 degrees. We want to find what is this side? What is this side? Yes. Given circle with center O. Given circle with center O. Center O and radius OB. And radius. We want to find what is the value of OB. To find OB. To find OB. Yes. For this, friends, what is given? Given OA is 5 centimeters. And that length of the tangent from A to the circle is 4 centimeters. And my friend, by the theorem 1, OB is perpendicular to AB. Implies angle OBA is 90 degrees. Is 90 degrees. Implies triangle OBA is a right angled triangle. Right angled triangle. Therefore, by Pythagoras theorem, we have OA square equal to OB square plus AB square. Yes, what is OA square is 25. We want to find OB square. What is AB square? 16. Therefore, OB square is 25 minus 16, which is 9. So, what is OB, my friends? 3. That gives OB is nothing but radius of the circle. Radius is 3 centimeters. Now, if it is an objective type, my friends, it is a right angle triangle. Two sides are what? Hypotenuse is 5, other side is 4. Definitely Pythagorean numbers. By the Pythagorean numbers, what is OB? Is 3 centimeters. 4, 3, 4, 5. Pythagorean numbers, but 5 must be hypotenuse. In that case, 3 is other side. 3 is other side. Hope understood. Yes, my friends. It is a given circle with center O. Length of the tangent from A to the circle is 4. And it is at a distance 5 centimeters. See, it is A is at a distance 5 centimeters from the center. Center means O. Then OA is 5. You want to find what is OB. Yes. Given 90 right angle triangle, Pythagoras theorem. Yes. This. Substitute the values. 9. OB is 3. What is OB? Radius of the circle is 3 centimeters. 3 centimeters. Yes, my friends. One more, the last example I do. The remaining examples, my friends, I do it in the next class. Yes. Next class. This is example number 6. Next example number 7. Copy 7. 2 concentric circles. two concentric circles are of radii 5 centimeter and 3 centimeter. Find the length of chord. This is a good example. Find the length of the chord of the larger circle which touches smaller circle, touches the smaller circle. What do you mean by concentric circles? Having the same center. Concentric circles means concentric circles have the same center. And different radii. Yes, my friend. And the figure is two circles with same center. This is one circle. This is another circle. This is another circle. Yes. This is the chord where it touches the small circle. This is the chord which touches the small circle. You want to find what is the length of the. This is center of the circle. Center of the circle is O. This is chord AB. What are the given things? This is 90 degrees. This is 90 degrees. Join OA. C. Radii. This is radius of the small circle. This is radius of the big circle, 5. You want to find what is the length of the chord AB. This is P. Okay, you want to find AB. This is the figure. Yes. From the figure we have or given OP, radius of the small circle, which is given as 3 centimeter. Next, OA, radius of the big circle. Of the big circle or bigger circle. This is given as 5. And what is AB? Chord. Chord of the big circle. AB be the chord of the big circle, which touches small circle, yes, small circle at P. Yes. Now OP is radius of the small circle. OP is radius of the small circle, and which is perpendicular to the tangent. Radius OP. Of the small circle is perpendicular to tangent. Otherwise, first we have to write here to find the length of chord P2. Length of chord AB. We want to find length of the chord AB. Same once again what? Radius OP is perpendicular to tangent. Tangent EB implies angle OPA is 90 degrees. Implies triangle OPA is a right angled triangle. Therefore, by Pythagoras theorem, we have, tell my friends, hypotenuse, this. OA square equal to OP square plus AP square. OA square equal to, by Pythagoras theorem, we have OA square equal to AP square plus OP square. AP square plus OP square. What is OA square? Is 25. This is AP square. OP square is 3, square is 9. From this, my friends, AP square equal to, which is 25 minus 9, 16. Therefore, what is AP? AP is 4. AP is 4. Then what is the length of the chord AB? Length of the chord AB equal to, what is it, my friend? And one more thing, this OP bisects AB, that we have to write. OP bisects the chord AB. Therefore, AB equal to AP plus PB. Bisects means what, my friends? It is AP plus AP. Bisects the chord AB means here itself we can write this AP equal to PB. They are equal. Therefore, put the value of PB as AP, which is 4 plus 4. 4 plus 4 is 8. Therefore, length of the chord AB here. You have to find the length of the chord. Length of the chord of the larger circle AB, which dices the smaller circle as P. Therefore, length of chord AB equal to 8 centimeters. Equal to 8 centimeters. My friends, this is a very good example. This example is appeared in June 2020 question papers under 3 mark. Under 3 mark 2020 under 3 mark. Last, I will explain my points once again. See, this is the question. Concentric means what? They are the two circles having the same center with a different radii. Radii 5 and 3. Find the length of the chord of the larger circle which touches the small circle. Concentric circles have the same center and different radii. Figure. From the figure we have OP, radius of the small circle is 3. OA, radius of the bigger circle, which is 5 centimeter. 5 centimeter. Yes. Let AB be the chord of the bigger circle, which touches the small circle at P. Then, to find the length of the chord AB, for this, once again, OP is the radius of the small circle which is perpendicular to the tangent at P. Perpendicular tangent AB at P. Therefore, angle OPA equal to 90 degrees. When this angle is 90, this triangle is a right angled triangle. So, by Pythagoras theorem, OA square equal to AP square plus OP square. OP square. Yes, put the values. Yes, AP square is 16, AP is 4. But OP bisects. The chord AB. Bisection means what? Two equal parts. AP equal to PB. Now, the length of the chord AB equal to, what is this? Chord AB equal to AP plus PB. But what is PB equal to AP? It is 2 times AP or AP plus AP. What is AP? 4. 4 plus 4 equal to 8. Therefore, length of the chord AB is 8 centimeters. 8 centimeters. My friends, good example. Yes, these are some examples from exercise 4.2, my friends. In the next video, next class, I do few more examples on exercise 4.2. That finishes, my friends, the 4th chapter, beginning part of what? The circle. Beginning part of the circle. Yes, my friends. Today this much is enough. My friends, thank you very much. Bye, goodbye, namaste, namaskara. My friends, namaste. Have a good day.